Welcome in this session with an update of Java on the Raspberry Pi. Last year here at FOSDEM already gave a first introduction of how you can use Java and JavaFX on the Raspberry Pi. And now I want to give you an overview of what happened in 2021 and what are the plans for 2022. I'm Frank Delporte. I write for my own blog and for Foojay.io about all things related to Java and the Raspberry Pi. I live in Belgium. I've been doing programming since I was 11 years old and got a Commodore 64. And now I have the same experience with the Raspberry Pi, this very cheap computer that you can use for a lot of experiments and build amazing stuff. I do work at Eve, where we built this amazing robot. It's a worker robot, so the goal is that it takes a lot of jobs out of your hands and works for you. We are in a development phase and we use a lot of Java on the back end. I also do Coder Dojo clubs where we teach kids to program, and that's actually where I got into contact with Arduino and Raspberry Pi, and all these volunteer coaches brought me into this completely new world of very inexpensive components, but yet very powerful. 2 years ago I wrote this book, Java on the Raspberry Pi, with a lot of getting started tutorials and the whole procedure that I took for myself to learn everything related to electronics programming with Java. But first, let me introduce you to the Raspberry Pi, in case you didn't know about it. So the Raspberry Pi is a very small Linux PC. It has everything on board to run Linux. Depending on the number of connections you need, or Wi-Fi, or memory, you have a selection of different boards. The most popular one, which is used the most, is the B version, the Raspberry Pi B4. You have it in 4 different versions with 1, 2, 4, or 8 gigabytes of memory, and the cost is up to 80 euros. And you can attach 2 4K displays to it. You have network, you have USB-C, you can connect a camera, a lot of possibilities. Another very popular one is the Raspberry Pi Zero, is the smallest one. And you also have the Compute 4, which is actually a board without connections, and you have to attach it to a hardware baseboard where you can add all the connections you need. There are different baseboards available that you can buy ready, or you can create your own to integrate it in the electronics project with really the connections that you need for your purpose. For this Compute 4, there are 32 versions, again depending on memory, on wireless, all these capabilities. Now in 2021, 2 new boards were released. The first one is the Raspberry Pi Pico. That's right, the price you see on this slide is correct, it's $4. So it's not a PC, it's a microcontroller. You can compare it with an Arduino. That's the kind of things you want to do with it. So it's also a C++ kind of language that you use with it, or MicroPython. Again, you can connect a lot of devices there, do electronic experiments with it. It has no Wi-Fi wireless on board. There are different boards already available with the same microcontroller, the RP2040, which have wireless search the internet for Pico. You'll find a lot of them already. It's only 1 year old, but there's a lot of different evolutions on this. And also released last year was the Raspberry Pi Zero 2. The W there stands for wireless, so it has Wi-Fi on board. And it's an evolution of the Raspberry Pi Zero, which already existed, but it has a 64-bit ARM Cortex processor, 512 megabytes of memory, but it's really powerful. If you compare it to the old Raspberry Pi Zero, it can run the same kind of applications 5 times faster. It starts up very fast. It can run Java. It can run JavaFX. So you can use this as the central heart of any kind of application that you want to create with Java, or with a touchscreen interface. All that kind of stuff is possible with, yes, a $15 PC, a Linux PC. Now, what is the big power of the Raspberry Pi? In my opinion, next to the price, is the GPIO. These 40 pins on top of the Raspberry Pi board which allow you to connect a lot of electronic components. So these 40 pins, some are power, some are ground, but some are data. And you can use these to control a LED, read the state of a button, but also read the state or control a lot of different applications or components. You have different protocols to interact with all these devices. Now all this is supported by the Raspberry Pi by default. And it allows you to do a lot of different stuff. And if you want to get started with this, I advise you to buy an electronics starter kit. If you go to eBay, you will find a lot of them in different price ranges, starting from, let's say, $20. But it all depends on the number of components you get in the kit, if there's an Arduino or a Raspberry Pi inside, and the number of wires and all the other electronic components. If you start with this, make sure that you have a distance sensor, some buttons, LEDs, a lot of resistors. An LCD display is a great thing to use. As you will see, it's one of the experiments I will show you later. Those are the basic components, maybe also a motor or a stepper motor, all this kind of stuff. If you have a little more budget to spend, another great thing is the CrowPi. It's a little suitcase which has all the components pre-wired, so you cannot mess up the wiring, which I've done before. The only thing you can mess up is your software, and as we are Java developers, maybe that's a good starting point. If it doesn't work, it's a bug in our software. You have a lot of these components pre-wired, and I will show you in a minute. You can also get started very fast with Java and an existing project which combines all these components and shows you how to use them. The main thing I want to talk about today is Py4g. Py4g is a library which allows you to interact with electronic components in a very easy way as a Java developer. So it's a Java library to make it easy to interact with these GPIOs on the Raspberry Pi. It's a Maven dependency that you can include in your project, but under the hood it will talk with native libraries to really interact with these GPIOs. So on one side you have the Java, the thing you know already as a Java developer and that you know how to use it. And on the other side you have the native libraries which are part of this library and which will interact with the GPIOs and bring the data from one side to the other side. The Py4g project was started by Robert Savage already in 2012, and in 2014 he presented this at Devoxx in Antwerp. And since then it gained a lot of traction, a lot of users. There was at a certain moment the idea that Oracle would include this kind of functionality in Java itself, but that never took off. So you still have Py4g as the main project which will help you to interact with electronics from Java. Now Py4g version 1, actually that is now it stopped. So that's done. It got some final releases in 2021, but we're not going to continue with that version. Why? I will tell you about it, but what we did last year is release 2 new versions. One was for Java 8 and included support for the newer Raspberry Pi boards, and also a version 1.4 which moved to Java 11, and what was already the start to move to version 2, which we had taken out some support for specific components because that was actually a big amount of work to maintain in the sources. But the main problem with Py4g version 1 was this native library inside which was talking to the GPIOs. That was Wiring Pi, and Wiring Pi itself got deprecated. So there were no evolvements there. There was no support for the latest Raspberry Pi versions, so we could no longer use that as the heart of Py4g to interact with the GPIOs. But on the other hand, we needed to evolve because Py4g is used in a lot of projects. If you look only in GitHub, you will see that there's almost 60,000 references to Py4g. So it is actively used, and we need to move on and find a way to fix this. Some example projects where it's used is this Street Theater robot is only one of them, which is a fun way of interacting with electronics and showing what you can do with electronics from a very different perspective as a software developer, for instance, or where you use professional electronic components. But there's also this example by Robert van Burg, which is also a contributor to the Py4g project. He has these medical cabinets which are used in pharmacies in hospitals, and they show with a green light which medicine has to be taken out of the cabinet by the pharmacist. And if you put your hand in the wrong part of the drawer, it turns red, so you're alert that you're taking the wrong medicine. So also this is using a Raspberry Pi inside to do the controlling of all these lights and which data needs to be shown. So we needed a way to evolve Py4g, and that has become Py4g version 2, which was also started by Robert Savage. So he already started this in 2019. With a lot of feedback from the community, also about ideas, how Java could be used better inside this library, and the new evolutions also in Java, like the modular approach and make Java modules. And that's what's being used in Py4g version 2. It is on Java 11, so we moved on also. Wiring Pi, this native library, was replaced by Pi GPIO, but also with Linux FS. So different ways to interact with these GPIOs to make it more flexible and open, and that it can evolve in the future if some of the underlying libraries would again get upgraded, that we can easily replace it with another one. If you go to GitHub, all the sources are there. You will find different projects, different repositories. You have the core library of version 2, which includes all the Maven, all the code which ends up in the Maven projects, libraries that you can download. But there are different example projects also there, a test project which is separate. So all these projects are there shared and open for everyone to take a look at it and contribute and have some feedback also. Now this is a very big slide with a lot of boxes, but just to show you that Py4g, the architecture of this library, really has a clear separation between all the functionality and all the elements, again to make it easier to maintain, to understand, to evolve. And if new features need to be added, it's just a new block or a new row with all the elements which need to be added to the project. Now, because we were evolving and we needed extra people in the team, we're happy that new people also joined. I'm now focusing also on the documentation and the organization of the project, but really there are a lot of extra people coming into this Py4g project. Robert van Burg, I already mentioned, he's an active user of Py4g, but also a contributor. And then we also have the support of the FHNW University of Switzerland, where they use Java as the main language in their programming classes. And they also combine this with both Java, Raspberry Pi, Py4g, Java FX. They also have gaming that they use, so FXGL they use for some projects. And complex programming challenges are solved or fixed, or they use Raspberry Pi to really build a project around that. Now, next to all these contributors, we also have other contributors, of course, who extended the documentation, provided demo applications, a Maven archetype. All this kind of stuff is ongoing inside this Py4g project. Now, to document everything, we launched a new website in 2021 also. And the goal of this website is to provide all documentation related to Java on Raspberry Pi. A lot of this documentation can also be found on Foojay, but Foojay aims to combine all the knowledge about Java, while Py4g really focuses on what can Java do on a Raspberry Pi, or what do you need to get started, what example applications can we provide, how do you build applications, examples where it's used in the field. All this is on the Py4g website. One part that we are now extending at this moment is how can you build Java applications for the Raspberry Pi or on the Raspberry Pi, because everyone has his own build tool or flow of how he wants to do things. I myself, I'm a Maven user, so that's what I was focusing on. But luckily, some people joined and made a Gradle example. Someone made a Java C example. We are now working with or trying to build with GraalVM, not native applications. Also, it's also ongoing. We know we have some 32-bit issues still, and also memory limits are important there to build the native application. Once you have it, running it is no problem. It's just the process to end up to a native application is still ongoing. GBang is already on my list for a long time that I want to experiment with it. So let's hope I can bring something to the documentation website also. SDKman to install Java on the Raspberry Pi is also something which is ongoing. Because the Raspberry Pi uses an ARM processor, it was not so easy to make SDKman aware of which version of JDK to install on the Raspberry Pi, but we are nearly there, and also that will be available soon, hopefully. Now, how do you create a little project with Py4g? Let's look at getting started, the minimal example application, which is part of the documentation website. It has a LED, it has a button, and the idea of this project is that the LED blinks, and every time that you push the button, the LED blinks a bit faster, and if you have pushed the button 5 times, the application stops. Now, the code to do this is very minimal because this is Java and we have a library to help us. So we have a context that we need of Py4g. And as soon as we have that, we can, for instance, configure the button. So configuring a button, it's a digital input. We want to have something read from an input. We define this as a button. We have to give it the address, the pin where the button is connected. And then we can add a listener and react to events which are happening in this listener. So you see, this is really Java code. The kind of code that you know as a Java developer. There's no magic here about how you have to configure the wiring or how you have to configure your interface with this button. This is all handled by the library. On the other hand, you can also define an output. So the LED is an output. You want to turn it on and off again. So here we have this configuration that we have to do, a config builder that you can use of the digital output. We create the LED and then we can interact with this LED. So we can put it low or high, on or off. So that's how you interact with a LED. Because this is a modular style of building a project, which is the default of Py4g, if you build this project with Maven, in the distribution directory you will find all the modules which are needed to run this project on your Raspberry Pi, and we even include a little shell script to start the application. Now, if you look into this little example movie, it just shows you that LED is indeed blinking, and each time the button is pressed, it starts blinking a bit faster. Now, the same thing that we have done with this LED and this button can be used to do some more complex stuff, build a game. And if you say building a game with Java and JavaFX, of course you end up with FXGL, the fantastic library by Almas, which is also part of this FOSDEM series, of course. And we have also for this an example which is fully documented on the Py4g website. You can also find some articles I've been writing for Foojay and the Java newsletter of Oracle. Another nice example of what you can do with Java and Py4g is a project where the CrowPy is used, so that's the little computer I was talking about before. As part of the Py4g project, we even have an operating system for the Raspberry Pi, which is a bit tuned for Java. So the idea is that we take the Raspberry Pi OS, the official operating system provided by the Raspberry Pi Foundation. We do some extra pre-configurations for JavaFX. You can download this operating system from the Py4g /download page. You can build it, burn it to an SD card, and then you have your full operating system working. There's some nice additions here, like the Ethernet and the WLAN address is shown as in the background of the screen, so you can find it back very easily, and you can connect through SSH. Now, if you want to get started and you have this GrowPy, or you can just look into the sources of this project, you can get them, of course, from GitHub again. This project has the way of controlling all the components inside this GrowPy, and let's look at one specific example, the LCD example. So it has an LCD display, an application to control the display, which actually uses some kind of chip to control it, and then you have I2C, which is the protocol to exchange data with this component. And this whole application makes it a lot easier to write text to such an LCD display. So writing a line to it, so this LCD display has 2 lines with each 16 characters. So you can write on line 1 a hello and a world on the line 2, or you can move the cursor, or you can have the cursor blinking, or you can even draw images on this kind of display. Like you see here, the right lower part of the house is with this byte array defined as an image, and you see the window as being zeros and the wall is ones in this byte array. Now, if you combine all this, you can have a lot of running fun examples on the GrowPy. Now, let me show you one final example where I combine Java and Raspberry Pi. I started with the GrowPy example project, and I altered it a little bit and created a post series for the HiveMQ blog, where I used this project to send data from these sensors to HiveMQ Cloud. So it's an MQTT message broker. And just to show you how easy it is to send data from a Raspberry Pi and read it on another one, or combine a lot of data inside one dashboard application. So first thing is getting the sensor values from the GrowPy. Because I started from this already existent example application, I could very easily read from all the different sensors inside this GrowPy, like for instance the humidity, the temperature, the light value. All these are read every second and sent to HiveMQ Cloud. On the other hand, you have these sensors which react on an event, like a touch sensor. As soon as you touch the sensor, a value becomes true. So when these values change, I also send them to MQTT. This way, different values are transmitted continuously. Now I can leave this GrowPy on one side, and it just sends data the whole time. On the other hand, I want to test if this data comes in, and then you can use a WebSocket test page, also provided by HiveMQ Cloud, where you can see all these values coming in. So you see that this data, which is being transmitted by the Raspberry Pi, is actually received somewhere on the internet in this broker. And now the fun part, you can read from another Raspberry Pi. You can use another Raspberry Pi to read from this MQTT broker and visualize the messages or the data which comes in. So I have this little JavaFX application which is using the TilesFX library of Gerrit Grunwald to very easily show each value received from the sensors in its own tile. Some of these events are transmitted every second, so the value changes the whole time. Others are event-based. So for instance, if touch a sensor, you see that the touch sensor slider will change also in this display. Or if you move with the GrowPy, you have a motion being detected. Now you see, this is all running on a Raspberry Pi. It is using the language that you know, Java. It's also using JavaFX to visualize, to build a graphical user interface. But you have this data flowing from one Raspberry Pi to another one, meaning that they don't have to be in the same network, because we're using an internet provided service to do this. And the fun thing is, if you use HiveMQ Cloud, it's by the way free for 100 devices. So it's very easy to set this up as a test and experiment with messaging if you've never done this before. Again, it's Java. There are libraries available to do this sending and receiving of data very easily, and you don't need a lot of code to do that. You can also check these blocks and all the source code through the Foojay website, where the full project is described. Now, let's conclude. What can we do with Java on the Raspberry Pi? Everything. Java is real, write once, run everywhere, also on the Raspberry Pi. The same goes for JavaFX, also that runs on your Raspberry Pi without any issue. And the fun stuff it really begins if you add electronics to it. So it starts with blinking a LED, it starts with reading a button, but the possibilities are endless. If you like this approach, if you use Py4g, please let me know. If you have ideas how the documentation can be improved, how the library can be improved, everything is more than welcome as an improvement, a pull request, whatever. Join any of the discussions. Also, everything is happening on GitHub. If you want to know more, I share my blogs on both WebTechie, my own blog, and on Foojay. I'm on Twitter as Frank Delporte. We have this own category on Foojay, and I invite you to build, experiment, and have fun, because that's what I really do myself. Oh, and one more thing, I always wanted to say this. This recording is actually made with Raspberry Pi, shot on Raspberry Pi is the hashtag on Twitter. This camera I'm looking at now is actually a Raspberry Pi. I can even show you with another one, because I have another one here. So this is a very cheap recorder, a camera. It's a Raspberry Pi inside the Raspberry Pi 2 Zero with the HQ module of a Raspberry Pi. And I can show you on the other side, it's the same thing. So I'm using Raspberry Pi myself to do recordings, which is a great way, and again, an affordable way to do this kind of stuff. So if you want to start experimenting with Raspberry Pi, it can be with Java, it can be with Python, of course, because that was the original idea of the Raspberry Pi. It can be with C, C# if you want, but take a look at this device. It's really powerful, it's cheap, and because of this GPIO header, as I said before, you can add a lot of electronic components, and that's where really the fun starts. So take a look, experiment, have fun, and let me know. Thank you.